All right, let's try another example here of these going over the mountain type problems with adiabatic expansion temperature changes. So let's say we had an initial temperature of 31 degrees and we had a dew point temperature of 18 degrees. And that would mean that 31 minus 18 would give us a 13-degree temperature drop needed to reach the dew point. So let's put 13 in here, and then we're going to multiply that by 100, and 1300 would be the condensation level. So we'd have to get up to 1300 meters to condense. Now, let's say the peak of the mountain is 2800 meters, and our condensation level is 1300. So that means we have another 1500 meters to go to get to the top. So 1500 is going to be, let's see, if it cools at the moist adiabatic rate or wet adiabatic rate of half a degree for every 100, that means that we just take 1500 times 0.5 divided by 100, and it gives us a temperature drop to get to the peak of 7.5 degrees. 1500 times 0.5 divided by 100 is 7.5 degrees. So remember, our dew point is 18, and that's where we were at. So if we subtract another 7.5, that gives us a temperature at the peak of about 10.5 degrees. And if the peak elevation, as we said, was 2800 meters, and let's say it's going to descend on the other side to a plane that is at an elevation of 1,000 meters, then that's a drop to the plane of 1,800 meters. And as it drops to the plane, it's going to warm up by 1 degree for every 100 meters. So that's 1,800 times 1 divided by 100, or an 18-degree increase in temperature from the peak. So at the peak, if you remember, it was 10.5 degrees. So 10.5 plus 18 will give us a final temperature of 28.5 degrees.